Hey guys, what's up? Today it's kind of the last day of new stuff for PVA for the time being. We will come back to position velocity acceleration in the second half of the year when we learn how to do integrals, right? We'll have a lot more open to us when we do that. But this is kind of the last part with derivatives. Once again, there's going to be a little bit today on calculators. And I kind of gave you guys a little bit of a preview of this in class on whatever the last day was, yesterday. But let's take a look at a couple of different types of problems. First one will be a calculator problem. Okay, so here's the problem. I'm going to give you a velocity equation. And I'm going to ask a question, though, but the question is going to be about speed. So we know that an object's velocity is modeled by the equation -8 sine of 2 pi t. And the question is, on the interval 0 to 2, so again, here's the question. Between 0 and 2 here, at what time or times t does the object have a speed of 5? What I really need you to take out of this unit that's really important is the vocab we use really matters. Anytime you hear the word speed, you need to be on kind of high alert, because a lot of times speed and velocity are used interchangeably, but they mean two different things in physics and calculus. So speed is by definition the absolute value of velocity. So what we have to remember here, when you see a speed of 5, you immediately need to think, okay, a speed of 5 could be, since it's the absolute value of velocity, right? Since 5 here equals speed, and speed is the absolute value of velocity, that means v of t could equal 5, or v of t could equal -5. If you think back to Algebra 2 and Algebra 1, when you were first solving problems with absolute values, right? We know that if we have the absolute value equaling a number, then what's inside the absolute values could be 5 or -5, right? Because a velocity of 5 would give you a speed of 5, so would a velocity of -5. So keeping that in mind is going to be really important. Okay, so this is a calculator question here. So what I'm going to do is I'm going to go ahead and graph this v of t function. I'm going to graph it on my calculator. Because they say that I'm only looking between times 0 and 2, I'm going to set my window, my x min to be 0 and my x max to be 2. And then sometimes looking at the function, you can kind of get an idea of, you know, what you should set your y min and max, like your range for this function. I know that sine itself can be as big as sine of a number, could be as big as 1 or as little as -1. So I'm going to set my y min and max between -8 and 8. So let's go ahead and look at that. So I'm going to go ahead and say -8 sine of 2 pi t. Remember, don't be looking for the t button, just use x, right? Instead of v of t and x and t, we're using y and x. Okay, but we get the idea. Now, before I hit graph, I want to hit window to set my window so I don't have to graph it and then go, oh, wait, I need to change my window and go back and change my window. on a time test like the AP test, that can buy you a few extra seconds. So, and time is our most valuable currency on that test. So I got my window. I'm going to set my x min at 0 and my x max at 2, right? And I'm going to do my y min at -8 and my y max at 8. Then I like graph to get an idea of what this function looks like. And for Precalc, we should kind of know what this function is going to look like anyways, right? It's a reflected sine, right? An amplitude of 8 and a period of 1. Okay, so again, I'm looking for, I want to find all values t that have a speed of 5. Okay, I'm going to show you 2 ways in which you can do this. Okay, there's a couple of ways that you can do this. Number 1, right? So when we look at this graph right here, we're looking for a speed of 1, 2, 3, 4, 5, right? And we can see that there's going to be 1, 2, 3, 4 values up here. And there's going to be, but we also have to consider the ones down here, 1, 2, 3, 4. So there's going to be a total of 8 t values. I may not solve all of them on this video, but you'll get the idea. So I'm looking for 8 different times here. Also pay attention to the question. Sometimes they just want to know how many times did that occur versus at what times did those occur. If the question was how many times did it occur, I can say 8 without doing any more work. Okay, but if I want to know the exact times, that's going to be a little bit more challenging. On our graphing calculator, okay, we can always trace x values, right? So I can trace 1.1, and I know when x is 1.1, y equals -4.7. But what we can't do is trace y values, right? And now I can arrow over and say, okay, I'm going to try and get this thing to be close to -5. But as you can see, it always ends up hopping over the exact y value that you want, or often does. Okay? That is not an efficient way to figure out the x value, right? Because we have to be accurate out to 3 decimal places. So what we do, anytime you want to solve, you know, a given y value to figure out what the x value exactly is, what we can do is just graph that horizontal line. So what I'm going to do is I'm going to graph 2 horizontal lines here. So going back, I'm going to graph the number 5, okay, so I can find all my velocities of 5, and I'm going to graph -5, so I can find all my velocities of -5. That will take care of all the times when the speed is 5. Each of those intersections here is going to be a solution, okay? So let me just solve for a few of these, okay? Again, I know where's my cursor? Right at this intersection here, there's a time value where I'm going to have a speed of 5. And at this one, and at this one, and then the 4 down here as well. Okay? So to find those, what I'm going to do is I go to second calc, and I'm going to use this intersect number 5. Okay, a very powerful tool. Oops, a very powerful tool when we're solving. Okay. Now what I need to do when there's multiple intersections, I just want to arrow using the left and right arrows. I want to arrow close to the intersection I'm going to try and solve for. Okay. As long as you're close, we'll be good. Okay. So it says first curve, right? And that's the function y1. That's my velocity function. I'm going to hit enter. And now it wants me to use the second curve. And notice it's on that, I think it's a red line. It's on that red line. And again, right now it's close to that intersection. So I'm going to hit enter one more time. And I'll hit enter a 3rd time to get my first answer is t equals 0.607. So we have an answer of t equals 0.607. If I wanted to find the other intersections, I just have to repeat that process. Okay, so let's say I want to go for this one. I just have to arrow my first curve over closer to that intersection. I'll hit enter. and it's already on the line that I want, so I'm just going to hit enter again and enter one more time, and t equals 0.893 would be the next one. Okay, and I can keep doing that. Okay, but I want to show you something important here. What if I want this intersection right here? Okay, in fact, I would probably find that one first because I like to report my answers from smallest to largest t values. To find this intersection right here, any ones with the negative line, you just gotta, there's a little bit of a catch here. So I'm gonna do 5 for intersect. Make sure you're actually trying this too on your calculators if you have them. So I'm just gonna arrow back so I'm closer to this. Okay, so I'm going for this intersection. Now when I hit enter, something interesting is gonna happen here. Okay, here I'll hit enter. It's wanting me to use this for my second curve because that was the second function I entered into my calculator, okay? But I don't want the intersection of this blue line and this red line right now. I want the blue line with this black line, I think. So what I have to do is I have to change. My second curve right now is using Y2. I don't want to use Y2. If I just hit the down arrow right here, it'll switch down to that curve that's down below. That's the curve I want to use. Now I can hit enter and enter one more time. So I get a value of t equals 0.107. Okay, so if you're going to graph two lines at the same time, anytime you use y1 and y3, you're going to have to make sure you do that. Okay, so that's one way of doing it. And again, if you're struggling switching functions, you can always go back, do all the ones for y equals 5, and you can just go back and delete that line. And then when you graph again, you only have 2 lines that are graphed, and you can find, it's just, you don't have to switch lines. Okay, so that's always an option. The other thing you can do here, okay, so that's one way, that's the way that I learned how to do it. Another way you could do this is when you go back and graph your original function, because I'm looking for a speed equaling 5, speed is the absolute value of velocity. So what you can do here is, instead of graphing -8 of sine of 2t, you can graph the absolute value of that. Again, absolute values can be found on your calculator by doing math, arrow over to the numbers, and you can call up the absolute values, and then you can type in -8 sine of 2 pi t. And now, when you do this, you're actually graphing the absolute value of velocity. And when you look at this graph, it's going to look kind of cool. Looks like a bouncing ball or something. And what you just graphed is the speed function. This right now is the speed function because it's the absolute value of the velocity. If you wanted to do it that way, then you only have to graph a line at 5. And you'll see we have 1, 2, 3, 4, 5, 6, 7, 8. All 8 of our intersections are with that one line. And again, you could go through and calculate those intersections. Okay, I'll just move to that first one and see if it's 0.107 again. And we see we get that same number. And then I don't have to worry about graphing both the line at 5 and the line at -5. Either way, you have to be very careful with speed. Okay? So if you want, you can go ahead and find all of those times. Just for the sake of the video's length, I'll skip that. I'll show you another question that hasn't been super commonly asked in years past, but has shown up, and it's an interesting one to think about. This will be a no calculator problem. Okay, an object's position is given by, or is modeled by, x of t equals negative t squared plus 3t plus 7. So that right there is the position. Okay. Sometimes they ask questions about its position on the x-axis. Let's add that in. Sometimes they ask a type of question that is about whether or not at a specific time if an object is moving towards the origin or away from the origin. So let's just make something up here. Okay, so this idea of moving towards or away from the origin is similar to an object speeding up or slowing down in that we're going to have to consider two different equations. So let's just get a conceptual idea here of what can be happening. So again, it's about an object moving along the x-axis. So again, here's the x-axis. Here is the origin, which is at 0. Okay? So what we have to consider for moving towards or away from the origin, okay, we have to consider two things. We have to consider the position of the object and the direction it's traveling. For example, let's say the object, I'll mark the object in red. Let's say the object is over here to the right of the origin. Okay? Now, I could be right of the origin, moving away, or towards the origin, right? I have to consider which way it's going. If my position is positive, what would my velocity have to be moving towards the origin? Well, to be going towards the origin, I'd have to be going left. For me to be going left, my velocity must be negative. Okay? So towards the origin, that could be x of t is positive, v of t is negative. That would be moving towards the origin. But let's think of another scenario. What if I was actually left of the origin? If I was left of the origin, to be moving towards the origin, I'd have to be going right. So another way is x of t could be negative, my position could be negative, but my velocity is positive. So what do you think the general rule is going to be here? Well, to move towards the origin, x of t and v of t must be opposite signs. Well, you could just memorize that factoid of information, or you can kind of just, reason your way through it, right? If I'm left of the origin, I have to be going right to be heading towards the origin. If I'm right of the origin, I must be moving left to go towards the origin. Let's use a different color for moving away from the origin. So blue is going to be moving away from the origin. So if I'm left of the origin, to be moving away from the origin, I'm going to have to be going left. So that would be x of t is negative, v of t is negative. Or if I'm right of the origin, I'm going to have to be going right. So x and t would both be positive. Therefore, the rule is to be moving away from the origin, x of t and v of t are the same sign. Now, I never memorized that as a student because I could reason my way through it. If the reasoning doesn't make sense to you, then go ahead and memorize the pattern, okay? But with this particular problem that we're working on now, I want to know at t equals 1, is the object moving towards or away from the origin? Well, again, I have to look at my function here. My function is a position function. So I'll just copy that down here. What you first need to understand is you must calculate both x of 1 and v of 1. So let's do x of 1 right now since we have the function already. X of 1 would be negative 1 squared plus 3 times 1 plus 7. 1 squared is 1. 1 times negative 1 is negative 1. Plus 3 plus 7. Negative 1 plus 3 is 2. 2 plus 7 is 9. So what I know is x of 1 is greater than 0. To calculate v of 1, I'm going to have to do the derivative, right? So v of t here would be negative 2t plus 3. So when I calculate v of 1, I'm going to get negative 2 times 1 plus 3. That's negative 2 plus 3, which is 1, which is also greater than 0. So since my object is to the right of the origin, because its position is positive, and since it's moving to the right, because my velocity is positive, we can say the object is moving away from the origin. Now to justify, I'm going to say because x of 1 and v of 1 are the same sign. Just like when we're doing speeding up and slowing down, you can't say the object is moving away from the origin because they're the same sign. We have to specifically talk about x and v, position and velocity. Okay? I should add in here, I'm moving away from the origin at t equals 1. Because at other times, it might not be moving away from the origin. Okay, that's it for today. I'll see you guys on Monday. We're going to start our review. Right now, I'm planning to test on Friday, a week from today. All right. I'll talk to you guys later. 2 chains. Bye.